Okay, so we are going to do some distance versus displacement examples, and your notes associated with the video will give you these words. So let's look at how far an object travels for different scenarios with distance and for different scenarios with displacement. So scenario number 1. We're going to start at the origin, move 3 meters to the right, 2 meters to the left, and then 5 meters to the left. So, if we want to look at our distance, we can simply add up the lengths that the object is traveling. 1 meter to the right, well, I don't care about the direction because I'm just adding lengths, plus, except we don't go 1 meter, 3 meters to the right, plus 2 meters to the left, plus 5 meters to the left. So 3 plus 2 is 5 plus 5. The distance this object traveled was 10 meters. You can just add those numbers up. Right and left doesn't matter. Where I start doesn't matter. But what about displacement? Well, now what direction I travel and where I start do matter. So let's look at the displacement. So let's first represent the world so we can visualize where this object is located at these various points in time as it travels. So there's our meridian, and we'll define that as x equal to 0, the origin. It says that the object starts at the origin. So here is its location, x initial. It moves 3 meters to the right. So 1, 2, 3 meters to the right. And if I'm at the origin, 3 meters to the right is that position, 3 meters. 2 meters to the left. And then 5 meters to the left. 1, 2. Okay, so we're going to define our world over to the left now, our negative world. So 3 meters to the right, 2 meters to the left, and then 5 meters to the left. Boom, 2, 3, 4, 5. We end up at this location in space. What is our displacement? Well, displacement is the difference between our final position and our initial position. Our final position in the world, is negative 4 meters. Our initial position in the world, and I'm going to take out that unit. I don't like to keep units in our equation because m is used for other things. So I end up at negative 4. My initial position is at 0. My displacement is minus 4 meters. I'm 4 meters to the left of where I started. And that's consistent with our diagram. Good. Let's look at another scenario. Scenario 2. Scenario 2 says we start at the origin. No, we set the origin. We start at negative 1 meter, move 3 meters to the right, 2 meters to the left. All right? When I'm doing distance, I'm only interested in the change in lengths, those length measurements, so I don't care where I started. I move 3 meters to the right, plus 2 meters to the left. My distance is 5 meters. I'm just adding the lengths. If I'm interested in displacement, we want to look at position information. Oops. So we need to make sure that we define those positions. So we have to define the origin. So there's my origin. We're told that our first position, and I'll just put on some additional hashes there, not really hashtags, just hash marks, okay? Each representing 1 meter. So just to give us a gauge. All right, so it says I start at negative 1 meter. That's a position in the world. My location is minus 1. That's at this spot. So here's my initial position. Then it says I move 3 meters to the right. 1, 2, 3. And 2 meters to the left. 1, 2. I end up at this location in the world. So what is my displacement? My change in position. Okay, well, my final position minus my initial position. My final position is 0. My initial position is -1. I'm at this location. So my displacement is positive 1 meter. Positive 1. 1 meter to the right of where I started, represented by our displacement calculation and is consistent with our diagram. All right, let's do one more. Scenario 3. In scenario 3, I start at 2 meters, move 1 meter to the right, and then 2 meters to the left. So if I think about my distance, I only care about the movement pieces. Move 1 meter to the right, plus 2 meters to the left. I have a distance of 3 meters. Displacement, we have to define our world and our locations. So here's our origin. And pick that first. Set it somewhere. Set your framework. So there's 1 meter, position 2. So I'll make these hash marks each 1 meter in length. Okay. So it tells me that I start at position 2 meters. There's my initial position. I move 1 meter to the left, and then I move 2 meters to the left. So I end up at this location. So my displacement, oops, I'm supposed to just pink and keep consistent, is equal to my final position minus my initial position. My final position, I'm at -1 meter. My initial position, I'm at 2 meters. And so my displacement is minus 3 meters. 3 meters to the left of where I started. Okay, so we can calculate displacement, but I want us to notice something about how the direction is related and really emphasize this idea that the direction of our displacement is relative to the starting location. It doesn't matter where the heck we are in the world. It's only relative to the starting location. So, in this example, we are sort of in the left side of the world, the negative world, but I have a positive displacement. So I can be over here in this negative world, moving and ending up right of where I started, and I'll have a positive displacement. Okay, I can mostly be in the positive world in this example, ending up left of where I started, regardless of where that is, and have a negative displacement. So it's really important to realize that displacement does not tell us where we are in the world. It doesn't tell us where we are. It only tells us where we are relative to where we started. So if I am in the positive world at positive 3 meters and I move to positive 2 meters, I have a displacement that's negative, but I'm still in the positive world. And similarly, if I'm in the negative world, if I'm at negative 20 kilometers and I move to negative 5 kilometers, I've moved to the right. I have a positive displacement, but I'm in the negative world. So it's very important to appreciate that direction of displacement does not tell us anything about where we are in the world. The only thing that tells us where we are in the world is the direction of our position. We want to keep reminding ourselves of that. Good job.